Okay, I'm going to stick to your first name.
Oh God, you don't know my full name. My full name is Caron Pas. So there you go. Yeah, and which literally means small steps, which is weird for a 6'2" guy.
You are a big dude. I feel at home when I'm standing next to Etienne, if that makes sense, Kaushik.
Oh wow, really? Okay. So
yeah, he's tall like I am. Yeah.
I mean, the first time I saw Don, right? So like we've only done like video calls, and so I haven't seen him, right? And so in Palo Alto, like the first time, like, hey, we should meet up for lunch, right? And I'm like, I saw him across the road. I was like, that guy looks pretty tall. Like, he didn't look that tall when I saw him like on the video. And as I came close to him, I was like, holy cow, you are tall.
It's time.
From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm DonnFelker.
And I'm KaushikGopal.
Welcome to the show.
Sometimes you look at the technologies on the horizon and think, wow, that stuff is so cool, but I wouldn't know where to start building that kind of stuff. I've had that opinion too of VR apps or, virtual reality apps. If only there was someone who could explain these things to me, in a way that I can understand, in a way that an Android developer can understand. Well, if you had that thought too, this is your lucky day, because we talk to Etienne in this episode, and he gets us up to speed on how one builds a VR app. After listening to this one, my first thoughts were, this stuff is not so different. It doesn't seem that difficult after all. Hope you enjoyed this episode on VR apps as much as Don and I enjoyed it when we talked to Etienne. Let's get started.
Kaushik, did you get a good night's sleep?
I did actually. So I'm not sure if you've been following the weather. Last week was amazing in California, but now last few days it's been raining again, so nobody knows what's happening with the climate here.
It's crazy over here. It's been freezing cold when it should be a little bit warmer, so it's what it is, right?
Yeah, I probably shouldn't complain too much.
Exactly. Have you played with like Google Cardboard at all, or did you get the Cardboard at I.O. a few years ago?
I did. I got the Cardboard and I got the Daydream. Once I got my Pixel phone, right? I also got like the VR headset because I was early enough when I ordered my Pixel phone. So I also got the Daydream headset, and yeah, I've used it. So the thing is, I've never actually thought about like developing for it. I mean, I have thought, but I haven't done anything about it. But I have used it, yeah. What about you?
I got the Cardboard years ago, and I played with some of the apps, and I thought it was pretty cool.
Mm-hmm.
But I never really dove into it too deeply, and I don't have a headset yet, though. My daughter keeps begging to get one because she really wants to try it out, but I'm afraid she'd probably walk through the window if I wasn't careful, So anyway, it's been something that's been very interesting to me, and I know that you and I have talked about this offline a few times, and we thought it would be best to get someone on the show to talk about it. And I think without further ado, let's please welcome Etienne Caron on the show. Welcome, Etienne.
Hey, guys.
Hey, how's it going?
Good. Nice to be here.
Now, Etienne, for the folks that are out there that maybe have not been familiar with any of your talks or presentations, which I've seen many of, can you give them a little bit of background about maybe who you are, maybe where you work, how long you've been developing on Android and so forth?
Yeah, so I'm Etienne Caron. I'm part of the GDE program, and that's due to my involvement in the Android community in Montreal. I work for a Canadian company called Shopify.
Oh yeah, I love Shopify.
Oh, thanks. So yeah, and otherwise in the community lately, in the last few years, I've been more and more getting involved in VR and all that good stuff because I'm a bit of a gadget hound to start with, really. So
nice.
Yeah, there's a lot going on there.
So how did you get into VR? I mean, was it as part of like some Shopify experience that you were trying to build, or was it just out of curiosity on the side and you said, hey, I'm going to just like try this thing on the side?
It's a funny thing because Shopify actually has a VR department and they're doing all sorts of super interesting stuff. Like I recommend viewers check out their blog. There's a lot about cognitive science in there and things like that, but I'm not actually part of that at all. VR is a hobby I picked up basically when I started out, like long time ago, programming in the 90s.
Oh, wow.
Yeah, there was this thing called the Demoscene. Oh, I'm revealing my age here, but
What is that? I don't know. I've never
I haven't heard
that.
of it. Yeah.
I think I'm pretty close to your same age as you, but I'd like to know what that is.
All right, so if you go back to the days where we didn't have internet and modems were running at 1200 bauds, people would basically share, quote unquote, their software just copying floppies, right?
Mm-hmm.
And so after a little while, people started putting little tags like graffiti on those disks. So those are called intros. You might have seen them or might have heard of them. So
Let's back up a second. Sorry,
Yeah.
what's a floppy? Oh, just kidding.
ouch.
Are you just one of those guys that clicks on it, don't know what it is? Oh, jeez.
I'm just kidding. I've totally used
off my
floppies too.
What are those icons about? It's
I
like
know,
those
right?
handsets.
Same?
right?
I'm right. That makes no sense. I'm just kidding. Sorry, you were going on. Yeah.
Yeah, well, so people would just basically put like graffiti on those disks. Like
Mm-hmm.
they put a little running program that would start before the actual game or the actual software would start. And they just say hi to their friends and brag about how they cracked the software and things like that.
I remember this. Oh my goodness, I do. I totally remember this.
That's
So-
funny.
What started happening after a while is that people started sort of competing on the merits of those little programs. They started sort of exploiting the video hardware of those old computers and trying to pull like better and better tricks, right?
Mhm.
For bragging rights. After a little bit, they stopped even putting it in front of software and they just made full disks of these intros and these demos. And before long, you had like actual weekend-long competitions where people would prepare a demo, just meet up, and they'd compete for prizes. And they were sort of your sort of proto-hackathons, if you will. And we're talking late 80s, early 90s.
Wow. Is that your kind of your what got you interested in VR or what was that like the catalyst for you?
Yeah, so I ended up organizing one of those demo parties like mid-90s, and my first exposure to VR came from that. So I got an internship out of it for summer, and we're talking 94, so this was really low tech, but you started having the first wave of really failed VR back then. So I got to try one of those headsets that would connect to a VGA card and would have like a glorious resolution, you know?
Oh, wow.
Yeah. So you'd have like, for the two eyes, you'd get something like 320 by 100 resolution.
Ooh, you do not want to
Yeah.
eat before that.
No, it was kind of, very dizzying, very sort of nauseous inducing for sure. Yeah. From those days on, like I really got interested. Fast forward after my studies, I started working and, like that hobby sort of died down for me, but I kept keeping an eye on 3D video, getting sort of interested and excited about all the new video cards that coming out and all that. So fast forward to a few years ago when they came out with cardboard, and I was definitely interested and started poking around and made it my hobby, basically.
So, VR is a kind of the general term. And I think we've just been throwing it around. Would you mind explaining for folks out there that really are out of touch with it, what exactly is VR? What's that acronym mean? Does it mean cardboard? Does it mean Daydream? Does it mean Samsung? Does it mean Oculus? Does it mean what exactly does that term mean?
Right. So virtual reality, right? That's the acronym.
Mm-hmm.
Things kind of get really fuzzy really quickly because if you look at virtual reality and augmented reality, these two things are starting to converge. But for the purpose of the discussion, like VR as we know it today is like 3D stereoscopic rendering on with a headset, right?
Mm-hmm.
And typically what that means is that your phone is going to render two images, one for each of your eyes. And that headset that you're going to put your phone in the case of Daydream and Cardboard, is going to make, basically the lens are going to make you see 3D in stereoscopy. So give you the full effect.
Stereoscopy, I'm probably pronouncing it. What is that?
So, right. So your eyes are basically seeing the world from 2 points of view, right? So the delta between those two things is how your brain sort of detects depth, right? So that's the effect that you're getting when you're using VR and you're using these headsets. To add to the illusion, what's nice about phones nowadays is we have like using all the sensors on board and the accelerometers and sensing where gravity is, you can tell where somebody's turning their head, right? So you can change the 3D perspective based on the person's head position, which is what gives you this effect of virtual reality. This is how you can suspend disbelief and really put people in those environments. as if they were there.
Yeah, I saw that. You guys probably saw this too, but it was that thing floating around the web where folks were standing on a 2x6 on the floor, but they had the VR headset on it, and it was like a plank. In the VR world, they had to go out and get like a kitten at the end of this plank that was on this skyscraper, and people were just terrified. But they were just on a 2x6 on a regular floor, but it really engulfed them to make them feel that they were way high up on a building.
Yeah, that effect is like really where you see the power of VR. For some people who haven't tried it, it's very abstract, right? People are like, why are people freaking out? This is just like a small, like 1-inch raised thing on the floor. But the thing is, our nervous system has evolved to sort of use the visual feedback as one of our main sort of drivers, right? So everything in your nervous system goes, I'm high up on a skyscraper, I'm going to die, right? So you can't help it for the most part, unless you get really used to it. After a while, you do get used to it, but that's part of the thrill of using VR for the first time. So if a listener out there hasn't tried it and gets a chance to try it, I would definitely recommend like going a little bit out of their way just to sort of play with these experiences.
You mentioned stereoscopy, right? Yeah, tricky word.
Yeah, I know.
The way I understood it is like, just for curiosity, like when folks are actually trying the VR, you should also remove your phone, like if you use like Daydream or like one of the other platforms, and look at it on your mobile, like just to see how it renders on the screen, like without any of the equipment, and you'll see it'll actually make more sense because it's like you said, it's tuned towards like you'll have two independent sort of like renditions of like video going on, right? And so you can see that they're trying to like sort of like make each, like they're building an image for like each eye, right? And then once you put it into like, the cardboard or like the headset, it sort of like builds that visual sort of like 3D effect.
Yeah, it's true. It's a very good way to get like an intrinsic feel, like a gut feeling on how this exactly works. Like, yeah. Totally.
So on those two images, I've seen that on the screen, and for those of you that are listening that have seen this too, I've seen those. They're two like little oblong images when your phone is in like in a landscape orientation. And you said something about depth perception that was interesting. And I'm just kind of asking the general question here. Let's say the image on the left portrayed an object closer to me, and then the image on the right-hand side of the screen made it look like it was further away. If I had that in a VR headset and I had it on, would that give me the perception that like something is coming at me from that angle, and that how my brain would perceive it?
Yeah, totally. So yeah, if basically the closer the object is, the bigger the delta on those two images is going to be. That's how you're going to tell that something is right up in your face, right? Whereas if things are like very, very far away, the effective perspective really gets diminished in a sense. Right? Something that's very far away, your two eyes don't really see a difference in where it is in space that much.
Which is kind of like if you look out your window and you see a tree that's, 100 feet away, and you move your head back and forth, it's kind of looks like it stays almost in the same place, right?
Yeah, totally. Like another way to try this, like, and just like get a feel for it, is just like close one eye, open the other. When you have something close to your nose, say, you're gonna notice. Oh yeah, it's true. Like this image doesn't look like it's in the same place, depending on which eye's open, right?
Everybody's doing this right now.
I just did it right now. I was like,
me too.
Oh yeah, my mic now looks at a different position. Never mind.
If you're driving, please open both of your eyes.
Yeah.
Yes. Keep those peepers open.
Yeah.
Okay. So we talked about cardboard a little bit. We got like the VR headsets out there that you can buy from Google and so forth. But we also have things like Oculus. Like, I don't know where that fits in the situation. I've seen some stuff out there that's like for Steam. Then I've also seen things like web-based VR. How do these work together? Are they different, or what's the situation here?
Right. So the big players right now in the space on the desktop side of things are Oculus and Vive, right? So those are what I think we can say popularized and really took VR to the next level. And the reason those experiences are so compelling is mostly because of the way that you can interact with a space, right? So in the case of the Vive, well, Oculus also has Oculus Touch now. So you have these remotes that you can hold in your hands, right? And this allows you to see your hands or to see what you're doing in VR. You can even get up and walk about a room, and you can interact with these virtual objects in that space. So you can pick up a ball, throw it across the room, or even catch something and get a little bit of haptic feedback on your hands, right? So this takes the stereoscopic aspect of things that you're going to get with, say, cardboard, and it brings it to the next level.
Got it.
Interesting.
So I had a quick question. Microsoft has famously done this with the Kinect, right? like a similar sort of strategy. So how is that like a different concept altogether? Like, I don't necessarily think that has anything to do with VR, but they do like use a similar sort of like aspect of like using the Kinect, and then that uses like imagery in some ways in like recognizing it, right?
Right. So they're basically putting two cameras and looking at at least they think it's two cameras of the Kinect. I might be wrong there, but they compare two images and they can see depth for objects coming at the setup. This has been used on VR rigs in a way. Like people used to, before Oculus came out, like there was a huge enthusiast scene where people would make their own headsets, and some people would put a Kinect on there to sort of be able to see their own hands in the virtual simulation, in the virtual world.
Oh, nice.
Yeah, that's
cool.
a nice hack.
Yeah, it's an interesting hack. I want to back up just a little. So I think I have an understanding now of what VR is, right? There is also AR, which is like augmented reality, right? And I know like if for folks who follow the tech news, I know like Apple is like apparently like Tim Cook or someone said like AR is their big bet versus VR, which is what like the rest of the industry is like betting on. Can you briefly also tell us what the difference is between AR and VR? Are they the same thing? Is it just a slight modification of one over the other?
Right. So AR is basically the promise that you can superimpose things onto your day-to-day reality, right? When Google Glass came out, a lot of people were really hopeful that this was going to be AR. And in a sense, it was. You would basically have a TV screen up in front of you that would report information. But proper AR, as we imagine it, is a bit like that movie with Tom Cruise. What was it?
Minority Report.
Oh, yes, thank you. That UI, right? Everybody started dreaming about AR basically there. Or if you think about the Terminator vision or RoboCop's like head-up displays, right? So that's what most people imagine when they think of AR. And right now, we don't have a lot of devices out there, but there is Project Tango from Google that basically sort of fulfills that promise, right?
Right.
You can have virtual objects superimposed onto the world. The only difference is you don't get to wear that on your head, right? Like you basically have a tablet that you look the world through, right? A magic window. Right.
And I mean, for folks who didn't quite catch that, AR is basically augmented reality. So like now your given your explanation, that makes sense. And VR is basically virtual reality.
Yeah, right, exactly. So you want to augment, you want to put things on top of your day-to-day reality. So you can imagine things like recognizing an object and telling the person with a little window on top of that object, what is that object? Or we see some examples of this in more industrial settings where specialized workers are getting headsets that are able to sort of superimpose diagrams for engine repairs and things of that nature.
Famously, Google Glass is known to have like not picked up in the consumer market, right? But I read this article recently where like folks still use Google Glass even today, like in certain manufacturing industries. Try to see if I can find a link to that. And it's exactly for the use case you mentioned. What they were saying in the article is typically they would go back to their desks, look up the manuals, instructions, like find out what the instruction is, go back and then feed those instructions into like the industrial machine, right? But now with Google Glass, they can essentially just say, okay, and essentially then say, bring up the manual for part A, Y, B, whatever the industrial part is, right? So there's still a lot of like applications there.
Right, or the old joke, right? Enhance.
Exactly, yeah.
It makes for very compelling use cases. The thing is that was kind of sad about Google Glass is the social acceptance wasn't there, right?
Right.
You have to wonder where it's going to go. Like for people that watch the tech news and follow it closely, they might have noticed that Project Tango has some sort of kinship with the Daydream team. So yeah, stuff I've heard is that those two teams are actually working out of the same offices, basically.
Oh, nice.
And and if you might have noticed an announcement from CES that was in January where the first AR, like the first Tango Daydream, or if you want AR VR combined phone, is supposed to come out this year, and it's going to be one of those Zen phones. I forget which one, but the Zen Phone AR or something like that. So we're going to have a phone that can do both augmented and virtual reality. So I'm kind of curious to see what kind of headsets are going to go with that phone.
Oh, that's awesome. We actually at Instacart, we use like Project Tango a whole bunch, like in like our shopper team. We started to use a lot of like Tango is amazing. It's just like it's crazy how advanced like the kind of things that you can do. But I didn't hear about this, the first phone where they have AR and VR combined. That sounds super slick.
Yeah, definitely. Like, I'm very curious to see how that's going to turn out.
You brought up something that's interesting. I think there's a lot of confusion about. There's Daydream and then there's Cardboard. What are the two differences between those if I'm going to be developing a VR app?
Right. So that's a good question. And a thing that not a lot of people know is that the developer kit for Daydream is called Google VR. And Google VR was actually born out of the Cardboard project. So if you go on their GitHub and you look at the history, it used to be the Cardboard SDK. And now it became the Google VR SDK and supports Daydream as well as Cardboard. So the difference between the two are basically one of hardware, right? Like, with what happens with Cardboard is that it's for every phone out there, but every phone out there is not really suited to do proper high resolution quality VR.
Okay.
Sort of a thought experiment, right? It was, if memory serves, it was born out of a Googler 20% project. Googlers out of Paris, I believe, that were involved in scanning art from the Louvre, their museum over there, right? And they were like, oh, we should do high quality scans and try to render those in 3D. And then they came up with this headset that would enable anybody to basically look at this art and make it available to the grand public.
Oh.
So that's where that was born out of. Now, fast forward a few years, VR is picking up. They just upgraded the kits, and now we have Daydream-ready phones. If you're curious, I could maybe talk to the specs, because I think a lot of people don't know what the differences are, right?
Please, yeah.
Yeah, so the thing with Cardboard is it introduced VR to a lot of people. What's kind of sad about Cardboard is not really that great. And there's a couple of really key reasons for that, right? So one of them is that the sensors in most phones are not super high quality, so the head tracking can be off, right, to start with. Yeah, so that's not great. The second thing is that a lot of the GPUs and phones out there are okay, but when you start doing more serious 3D rendering, they're not that great either. So Daydream-ready phones are aiming to hit that spec where they can do 60 frames per second consistent rendering without sort of having any hiccups or latency.
Got it. That makes sense. And the thing that I guess folks also have to realize is, even like on mobile applications, we say, hey, you should really, like, you don't want jank and you want like the 60 FPS to be met. With VR, it's so much more important, right? Because like a jank in VR, at least I think it was like Romain Guy who mentioned this, but like a jank in VR can like really, really be problematic, right? Like you really have to hit that FPS if you want a smooth experience, because then you're probably going to give like the user a headache or something along those lines, right?
Yeah, and then it's kind of the same thing when you read in a car, right? Motion sickness is basically when your visual is not according to what you're feeling. So if you're in movement and nothing in front of your eyes move, your whole nervous system is going, like, for some people it's worse than others, but your whole nervous system is going, what's going on here? Why am I? And that disconnect is what causes motion sickness.
Oh.
And for some people, it can be pretty bad.
That makes so much more sense now.
There's another point I'd like to mention to people that they don't know about for VR. One of the things with those new screens that's really interesting is the low persistence modes that they manage to have. So if you imagine your eye being a camera, right? With cameras, if anybody that's done a bit of photography, people are aware of exposure, right? When you have low light condition, you put exposure to the max, and then you're going to get like a nice crisp picture, even if it's nighttime. The thing with our eye is that there's no shutter, right? You can't control the amount of light that hits your retina. So the thing is, if you're staring at a screen that's an inch away from your eye, after a while, pretty instantly, you're going to get persistence of vision problems. So you're going to get big white trails everywhere. You're overexposing your eye. Those new screens, for each frame that's being rendered at 60 frames per second, only will turn on the screen something like a third of the time. So the 2/3 of the time that the phone is showing you a frame, it's off.
Oh, wow.
So it just blasts your retina with a short burst of light. It stops. And then it picks up again on the next frame.
Whoa.
Oh, I didn't even. Oh, I mean,
didn't even know that.
Yeah, I had no idea about that. So 2/3
Yeah.
of the time it actually is like the screen's off.
Yeah. So if you try Daydream with, say, the Pixel phone, right?
Mm-hmm.
If you turn on Daydream mode and you take it out of the headset and you compare it with a phone running a Cardboard app, you're going to see that difference right away. You're going to see that the screen on the Pixel kind of shimmers. you can sort of detect it on a yeah. So
That is so cool. I had no idea about that.
yeah, it helps a ton with quality. It's the same trick that the big players like the Vive and Oculus headsets on desktop are using. Except for them, it's even better because they have 90 frames per second instead of 60. Right? That's the other metric that they're trying to hit to get good quality. Yeah.
Let's move on here a little bit for folks that are really interested in VR, and I have been for a while now. If I wanted to start writing an application for VR, is there a certain amount of gear that I need? I'm assuming I'm going to need a decent headset. Looks like I'm going to need a more high-powered device. I'm going to go targeting Daydream. But kind of the big question is like, how do I write a VR app? If you just kind of had to give me the high-level view, is it something I can write? Do I have to know like low-level C? Can I use Android Studio? Can I use Java? What and how would I go about doing it?
Right. So there's actually a lot of options, right? In my own talks, I target app developers first thing. So I target Java, and typically I'm going to go with Java and OpenGL or one of the libraries out there like Rajawali. That's an abstraction on top of OpenGL. The reason for this is if you think about the whole platform, there's a ton of Android developers out there. They have a huge skill set, right? And for doing advanced computer graphics, it's not always a very obvious thing. Like a lot of people, so OpenGL is the standard on Android, right? And not a lot of people play around with OpenGL. And the reason is basically fairly simple. It's that a lot of the times you don't need those frequencies, right? You don't need to go play into that specific range of things.
Well, what does OpenGL do for you? Like I'm kind of an OpenGL, dolt. I really don't know what it is, what it's used for, why I would even want to use it. Can you give me that kind of basic rundown?
Yeah, totally. So it's OpenGL is actually ancient by computing standards. It's a library that was born, I think, out of the 90s, if not even the late 80s. But let's put it at around the 91 era. That used to be on big-end desktops, like big-end stations. You need to buy those Silicon Graphics machines before you could use something called OpenGL. With time, it got more and more standardized. So the group behind OpenGL is called the Kronos Group. If you Google that, you're going to find their website. They have a whole lot of standards, but this specific one, so GL is for graphic library. That's worth mentioning. And you have OpenGL both for desktop and OpenGL for mobile. So the specific version we're targeting on Android is OpenGL ES. So what does OpenGL give you? It gives you a way of accessing the power of the GPU on your device, basically. So it's
Does this involve using the NDK? Like, I mean, does that mean with OpenGL I'll have to use the NDK?
So you don't have to. Like basically, it's if you look at the code in the AOSP behind OpenGL, it is really you are accessing basically a native library. Like there's basically a shim on top of native stuff.
Oh,
but you
got it.
Totally get access. You totally get access to it in Java.
Okay.
You don't have to do that. You don't have to go the C route.
Okay.
And it's debatable to there's always these old debates about performance, right? Like a lot of old school native types are going to go, well, C is always going to be faster than Java. And in some respects, that's true. But for most uses, even in OpenGL, like doing graphics programming, you can get a lot done just being in the Java space.
Nice. Yeah. I guess and I think correct me if I'm wrong, but I think the reasoning there was with C, you can control a lot of like the release and holding on memory, in a more granular fashion versus in Java where you rely on the garbage collector, right? So essentially, I guess that's where like you can really tweak the performance to work in a way where you can control. But then again, it comes with the beauty that is the C API, right?
Yeah, totally right. The thing to note, like when you start playing, like I'm hoping people will be inspired hearing us talk about VR, but if and when you start playing around with OpenGL, you'll notice that a lot of the programming is about creating byte buffers that you're going to be sending over the fence to OpenGL. And the rest of most of the things that people have to learn when they start doing OpenGL ES is how to program something called shaders. What's kind of interesting with these graphic pipelines is you are sending bytes over and you are writing short programs in a language that's close to C that will process this stuff and then render it out to screen. So you're actually meta-programming the whole pipeline.
That is a very succinct description of how it's done. That actually makes, if I'd heard that before, that would have made so much more sense.
If anybody's familiar with RenderScript, OpenGL is almost a one-to-one to RenderScript. If you've done a RenderScript kernel before, you will understand what OpenGL ES is like, definitely.
So when I hear all this, I hear like metaprogramming, I hear everything, like my brain starts getting a little bit of fuzzy. And then I think, like all I wanted to do was like put like a 3D dice on the screen and make it spin. And I hear this and I kind of get scared. I'm like, well, I don't know. Is that well beyond my capability? Is that something I can't bang out in a weekend because I have to learn these 20 other things before I can even hop into VR? Or is there a way that I can get into this as an Android developer and get that quick feedback and that quick, all right, look, I made this cool little project this weekend. Is there anything like that?
I think it's accessible to everybody. Like, obviously, I'm all about creating that content to get people onboarded. Like, my dirty little secret is I'm really hobbyist. I'm not really all that great with this stuff, but I can definitely bang out a few demos here and there and a few examples. And it's a lot of fun. Like, it is definitely accessible to somebody. If you've ever done linear algebra, even if it's like 10, 20 years ago, which is my case, you just need to review that stuff a little bit. A lot of the libraries are going to do all the math for you. As long as you sort of know where to put the right numbers in the right place, you're going to end up with that little 3D shape on screen. And making it into a VR example is actually extremely simple. Basically, the Daydream, the Google VR SDK specifically, is all about programming a scene in OpenGL, and then it will do all the hard lifting to turn this into a stereoscopic view for you. So that's the interesting part. And then it provides you with a ton of nice affordances where you can grab the metrics and the position of the remote. Like, all of these things are taken care of for you. So it's a really nice space to experiment in.
And I know both of you are gentlemen, so you're not going to bring it up. So I think it's my responsibility to bring it up because folks should know. You've started a course on Caster.io about VR as well, right?
Oh, yes.
So
I encourage people to check that out.
highly recommend it because, Etienne also has like a very succinct way of like putting a lot of like this stuff. So it's like he makes it seem very easy. Although honestly, I feel it's like a little more difficult. But if you walk through the Caster videos, you'll see like in no time you can get some of these banged out pretty easily.
And it opens up a whole world to you. Like, the interesting part is that a lot of people shy away from this stuff because it looks so sophisticated, right? They haven't done 3D graphics before. But once you start playing around with these things, like, you get that awfully good feeling of, hey, I've just done something insanely cool, right?
Absolutely. Yeah,
you want to hit that note, and everybody can do it. I'm convinced of that.
Let's talk about that for a second and rewind a few steps. We've covered what OpenGL is. It makes sense. I kind of have my brain around a little bit. I have Android Studio open. I have a new, Nexus device or a Pixel or whatever that can run these nice programs. At this point, I'm sitting down in front of my computer and I want to start writing an app. What are the next steps?
Right. So you need to learn a little bit about various stuff like the GL surface view. So if I don't know if we should get into that specifically.
Yeah.
But
we should. Sure. Yeah, let's start.
Yeah. Okay. Cool. So the big things to remember from an Android, like a pure Java Android developer's perspective is.
And sorry to interrupt you. Am I writing an Android application? Are we still working with fragments and activities, or am I writing just a Java app? Just to kind of clarify.
Yeah. So totally, right? Like, you're actually writing a very standard app. The only big difference is what you're going to be putting into your view. So your layout is going to be a full screen. Say we're doing 3D, like a VR 3D. So your screen is going to be basically a full-on surface called a GL surface view, which is like a very standard Java class.
So instead of like a frame layout or instead of a linear layout or something that I'm otherwise used to using, instead, the view object that I'm using is a GL surface view.
Exactly. And there's only one really big difference to keep in mind, and which is probably the trickiest bit, but it's not that hard when you get into it, is that surface view will be drawn on in a different thread. So that's the tricky bit.
Right. Yeah.
But if you're used to UI threads, it's not that tricky, really. You're dealing with two different ones. The reason for this is you want to get 60 frames per second rendering. So what happens when you create these surface views is that you're going to have to provide something called a renderer to the surface view. And that renderer is where the commands to draw to screen are going to be. So the next thing that happens is that once you start the rendering, like you have two modes. You have continuous rendering, and you can even actually program OpenGL and the surface view to render only once. So you don't have to have animation. If you want to do a funky graphic in 3D and you only want to render one frame of it and have that there, you can do that. Typically, though, you're going to be in continuous rendering mode, which means that your draw method is going to be called hopefully 60 frames a second. If it's slow, maybe less, but you're always trying to aim for 60. And that's the big difference. So going through, going over that divide between the two threads is where it kind of gets tricky. But if you're used to sort of separating, like basically the rule is simple, is don't change state in your GL draw methods from the UI thread or from another thread, and then you're golden. So that's the big difference.
Got it. And just to rewind back, GL surface view is an actual view that is provided to you. It's an actual view object that's provided to you by the Android APIs. For folks who've worked with camera stuff, right? Essentially, the surface view is something that you attach your camera manager onto. In a similar fashion, you have something called a GL surface view, which is what you use, I guess. Right?
Exactly.
Is there any third-party libraries that you use to make this maybe a little bit easier so I don't have to really get down into the weeds to do some of this stuff, or is there not anything like that yet?
Yeah, so the one that's typically used is Rajawali. So if you look at Google's demo code, like example code, you're going to find a lot of little samples that are using Rajawali. It's a very nice library in the sense that it takes away all the complexities of setting up surfaces, and because OpenGL, it's a bit of a dated library, to be honest. So you end up doing a lot of single steps to just get to render something on screen. So Rajawali takes care of all that trouble for you, and you end up only having to create a scene in a very natural way. So people can understand fairly quickly, okay, I need to create 3D objects, I need a lighting source, and you set these up with 1 or 2 lines per item. And before long, what you have on hand is this 3D scene rendering. Ultimately, under the hood, it's all GL surface view, it's the standard APIs, but you can get there a lot quicker.
Got it. And we'll make sure to add links to the show notes about like some of the Google demos you're mentioning and the libraries you're mentioning.
Yeah, totally. They're really the best to look at.
Now, we are an Android here, so we probably have a switch if it's a Samsung device, but that's another topic.
Hey now.
No, but we are Android developers. We have to worry about memory and resources and all that kind of stuff. Are there any concerns that we should be aware of when we're developing for VR? Anything we should kind of keep in mind when we're doing to be careful of?
Yeah. So. When the GPUs are on for a long time, basically the devices tend to warm up, tend to heat up. And what happens often, like Daydream phones are sort of built to mitigate that. But depending on how much you're asking out of the device, eventually the devices will actually slow down. Like they heat up too much and the system's going to start putting constraints on what you're doing. So that's something that you have to keep an eye on. Those are sort of the concerns that are kind of different. Otherwise, writing apps for VR is very similar to writing a standardized app, except, of course, for the GL stuff.
When it starts heating up, does the frame rate get lowered, or what's kind of the consequence there?
Oh, yeah.
It's going to depend, but most of the time, your frame rate's going to start getting janky. Things are going to start getting sort of unpleasant, basically. So, yeah. And this, funny enough, it has to do with the complexity of the scenes very often, or what kind of demands you're putting on the GPUs through your shader code. And that's where really the experience comes in, right? Like I don't have that kind of experience, like I'll be very honest with you, but that's where I see very experienced graphics developers shine, right? They can basically make extremely good looking scenes without making them very heavy, which used to be the whole hobby with the Demosceners back in the day. It used to all be about optimization and high frame rates. And sometimes a high frame rate is also all about having a high frame rate without putting too much constraints on the system.
Got it. So you said heavy, and a thought came to my mind. If I built like an actual VR app, right? Like you said, it's very similar to building an Android app. How is it different? Like, what are the sizes of these apps? Because I remember like Google has a VR store, right? And some of those apps are crazy huge. But I imagine that's also because they're doing like crazy demos, right? What's the typical app size like for a VR app?
So that's a good question. If you're making games, you're going to get up there, right? Like you're going to have a lot of assets, a lot of nice audio, a lot of nice textures and video and whatnot. I think most app developers out there, if they're like me anyway, they're going to think more about procedural content generation, which is in itself a fascinating subject. So what's kind of interesting is that we're going back to the early days where having smaller programs is actually a very good thing, right? Our mobile devices very often are going to be running over a cellular network. So if you manage to write an app, even if it's a VR one, that can create compelling content without being too heavy, you have a definite competitive advantage there. Like, we're probably not going to be talking about AAA blockbuster games or anything like that, but I mean, there's definitely space for people who know how to be sort of thrifty with their resources.
Got it. And I did mention the Play Store. So there's a specific VR Play Store just for like the Google stuff, right?
Yes, totally. So, and right now, that's actually a good thing we should mention to people. So if you want to write a Daydream app, you can, of course, do it totally on your own and run it and debug it. There's no problem there. But right now, for the moment, you do need to have approval from Google if you write an app and you want to put it up on the store. The good news there is that eventually we were told they're hoping to open it up to everybody without necessarily having a gatekeeper of sorts. But the thinking behind that is you want to build a platform, right? You want to have early adoption. You want it to be sky high. So you need to make sure that the available apps and games and experiences are going to be top notch.
Got it.
So that's why the walled garden still today. But the good thing to note is that should be, anyway, if we follow the promises that have been given out a bit, that should be sort of open to all developers sometime this summer. Well, I'm just basically guessing here, but that's sort of what was hinted at so far.
And I just want to back up. I forgot to ask this because now I'm super inspired and I'm curious to see how I could build VR apps, right? I've got a Daydream headset, but for folks who don't necessarily have that, is there like an emulator equivalent for this? Like how exactly if I build it, like how do I test this thing?
Right. So that is actually a bit tricky. So you can totally run the VR SDK against an emulator. The only gotcha at this point is that you're only going to get access to OpenGL ES 2. So there's multiple versions of OpenGL ES. The very early phones had OpenGL ES 1, which was not a programmable pipeline. So that was a throwback to the early 90s of OpenGL programming. Nowadays, any modern pipeline should be programmable. You can write shaders. That's very important. You get that with ES2. But you don't get the latest advances. So you will need a physical device, but you can get away with experimenting for the weekend on a typical emulator.
Got it. And I can use a cardboard for this, right? Or is that...
Yeah.
Yeah, okay.
Yeah, for sure. I mean, it's not going to be awesome, right? But...
Gotcha. Yeah.
It's totally worthy for experimentation. That was the big draw for cardboard. Anybody could do it.
Right. That makes sense.
Now, in the future, everything's changing at all times when it comes to technology in general. Is there anything that you see in the pipeline coming down that's maybe going to help improve the development of VR apps?
Yeah, we're very much in the very early days of VR, and that might be the tricky bit. If you wanted to say tomorrow start a company that made apps for VR, it would be a bit tricky, right? It's not clear which platform is going to be the winner. It's not even clear what kind of hardware we're going to get like 6 months down the road, but that's also why it's so exciting. A lot of the really interesting things coming up, something, I'm probably going to mispronounce this. So you have something called foveated rendering. So that's fancy wording just to say it's fancy wording to describe devices that can track where your eye is looking at on screen.
Got it.
Yeah, so they've come out with these new headsets that are going to be able to see where your eye is looking and only do high resolution and high quality rendering at the spot your eye is staring at.
Oh, that's awesome. Right? Oh, okay. So it can really push like the performance sort of thing, right? So it can like get like all the performance and like focus it at certain like points.
Yeah, exactly. Because your eye doesn't see in perfect focus all around it, right? Like you focus on that point. So if you only render the super high quality stuff at that point, your GPUs are going to be much happier and much cooler that way, right?
That's such a cool concept. Yeah.
The other crazy thing that I've seen in the news in the last few months, and if somebody's following this, they probably saw that too, but Qualcomm has like these dev headsets coming out that have foveated features and also have what's basically a Connect. Well, it's I think it's the company's called Magic Leap. So they have two cameras in front of the device that can see where your hands are in 3D. So you suddenly have a 3D VR experience where you see your hands and you can basically manipulate objects. And that kind of stuff is going to do wonders for everything that has to do with like suspension of disbelief and really awesome simulations.
Wow. This is like some super crazy cool stuff coming along the way, right?
Yeah, it's a very exciting field, definitely. I can't wait to see what's going to happen.
I think some folks that are probably listening to this, and this is kind of where I sit too, is, you did discuss some of, we don't know if this is going to be the solution of VR, if it's going to be around or if things are going to change. So some people might be wondering where or when should they invest time or what would be the best place to do it. Do you have any tips in regards to that?
Right. So I'm very bullish personally on the Daydream platform. I think it's one of the first really wide access ones that's really good quality. Like the Vive and the Oculus are awesome, obviously, but they are pretty costly to get. So yeah, that's the big thing. The other platform to mention that's kind of linked to all of this is that if somebody wanted to get into more like the game side of things, learning Unity might be a very good thing. So people might not be familiar with what Unity is. It's a game programming engine.
Okay.
So what's kind of interesting about Unity is that you can target multiple platforms with this game development engine. So you can make games for Android Daydream. You can make games that would use Tango. You can also target Vive, Oculus. So all of these things are available to you. So if you're really more looking at developing a game than, say, maybe most of our listeners here that are interested in building apps with using VR. So if you're looking to do games, Unity is probably a good skill set to get, because that's going to stay relevant for the years to come for sure. And personally, Daydream, I feel, is a pretty good tech, especially if you're going to develop with Java and OpenGL. OpenGL in itself is not going away anytime soon. It's like a standard, right? You can, whatever you learn on that, you'll be able to carry it over to iPhone, to desktop, to what have you. So that's a nice place to start. And if you're really looking to the future and are not afraid of a little bit more complexity, as if we didn't have enough,
right?
There's a new graphic standard called Vulkan that's coming out from the same group that that takes care of OpenGL, called the Chronos Group. So Vulkan is the next generation of graphic libraries that's truly going to be cross-platform. So you're going to use the same system both on Android. It's already available for Android and Nougat, and you're going to also be able to use it on desktop, consoles, what have you.
I remember during the announcement, Romain Guy was the only one who was like super excited about this. Like, he was the one, and we are getting Vulkan, and everyone was like, and he was like so excited. And
well, we should all pay attention to what he likes, like, because that's going to be the standard in a year or two, I'm thinking.
Absolutely. And you mentioned Unity, just to let our listeners know, Unity is C#, right?
Yeah. So that used to be for me a bit of a blocker when I'd recommend things to people, especially Java developers.
Oh, really? Okay.
But if you look, JetBrains has a new IDE. I think it's still in early access. It's called Writer, if I'm correct. And Writer works on Mac, on PC, and it hooks up really nicely to Unity. So you get the full power of the JetBrains suite that I think a lot of us really love to use, and I can't live without personally. So that's something to explore as well.
All right. And I mean, actually, like, both, I know Don and I are big fans of C#. So it is a very nice language. Like, if you can deal with Java, you can definitely deal with C#.
Yeah, I came from C# over to Java after being in C# for many years, and I felt like I stepped back in time. I'm like, whoa, wait, we don't have lambdas? And like, this was like back in like 2008. I'm like, there's no lambdas in Java? I'm like, oh goodness, like for loops everywhere.
Yeah, that's very true. Actually, I should put out a warning though. Unity's C# version is kind of old. which is the slight caveat there. So we're talking about. I don't know which version of C# we're talking about, but we're talking circa 2007. So I don't know if they had lambdas, or I haven't played enough around with it to know. So, but just a small warning to people.
And another quick follow-up question. You mentioned Unity, right? Have you actually worked on games with Unity? Just basic games can be built like typically with Unity.
Yeah,
right?
totally. So one of the things, like I have to say, it's more of as an observer, I have to report this, but I do some community involvement and with a group, a nonprofit here called Osmos in Montreal, and they do hospital visits for kids, for sick kids and things like that.
Oh, wow.
Yeah, so they bring VR to those kids and let them experience different environments, and they've been building their own environments using Unity.
That's wonderful.
So definitely, and a lot of people that come on to those projects are like community volunteers that have sometimes no previous programming experience. So I've seen a lot of wonderful stuff being done with that, where people just come together, right, and build new things. So totally, yeah.
We'll add a link there into the show notes for this as well. This sounds like an amazing program.
Yeah, no, definitely. If people can check that out, like it's an example to be followed. I think every city could be doing a program like that. Like we've had a lot of success with it. People really, a lot of impact. Really cool stuff.
Fantastic. Okay, so I'm sufficiently inspired. I want to build a VR app. I want specific resources. Like you said, some of the generic things that you think would work, right? I'm going to kick it off. Your Caster.io that I mentioned before is probably one. I'm going to drop that into the show notes right away. I think that's amazing. Are there any other ones that you use? Like, what did you use before you built this Caster.io course for us?
Right. So when I originally learned OpenGL ES, my first go-to, weirdly enough, was Apple documentation. So we can probably drop a link to that. It's very well put together. Totally applies to Android development. I mean, OpenGL ES is the same on both platforms. There's also a very good series called Android Learn OpenGL ES for specifically Android. The website is learnopenGLES.com. So that site is a very good reference. It's a bit older, but to get started and learn all the basics of ES2, which will help you sort of plunge into the later versions, totally recommended to check that out. If you want to get inspired and see what crazy stuff the kids are up to these days, go see a site called shadertoy.com. Very interesting site. It runs off of your web browser, so you're going to be able to see some of the effects. So these this is a free repository, an open repository, I should say, of shader code. So the shaders we mentioned that you use to program the pipeline, you can take that code and most cases drop it one-to-one in your own shaders and make crazy effects. There's all sorts of things there. You can waste days just exploring that repo. It's really, really cool. And Rajawali is also a really important library to check out if you want to get started very quickly. And the developers.google.com has a lot of really good documentation, good example code. Definitely check that out.
Yeah, I just want to say the caster lesson that you did, which is great. There's actually a free lesson. You can build your first Google VR app in 10 minutes. And the amount of content you cover in that 10 minutes is phenomenal. When I got done watching that lesson, I was literally thought to myself, wow, okay, I really feel like I have everything I needed now to get set up and get going. So highly recommend that. Again, it's free lesson. Check it out.
Awesome. And if people have suggestions, by the way, by seeing that, I would love to hear from people, how they manage to follow along. If they have anything else they'd like to explore, I'd really like to hear about that.
Well, where should they do this? Is there a convenient place that you would like to take in requests and maybe questions and other cool stuff about VR?
I believe you can leave comments on the Google VR course, the free course on Caster. And otherwise, I usually I ask people to sort of get in touch with me via GitHub issues, which might be a bit of a weird thing, but that's really an easy way to sort of reach me and do requests and things like that. Nice.
And do you have a Twitter handle handy that people can reach out to you?
Right. So I'm so bad with social stuff, those social networks. Oh, those newfangled social networks. So my Twitter handle is Kanawish. So that's Kanawish.
Okay.
And you can find me there, and I'm usually responsive.
Perfect. We'll drop that into the show notes as well. And Don, if folks want to join you on your VR learning experience, where do they do that?
They can follow me at DonnFelker on Twitter. That'll be the best place to reach me. And finally, where can they get a hold of you, Kaushik?
Kaushik Gopal on Twitter is usually the best place. Fragmented Cast is our Twitter handle. for the podcast. So if folks have any additional things that they want to reach out to us, that's a good place. Thank you all so much for listening. Again, Etienne, thank you so much. This has been so enlightening. I'm super stoked. It's going to be difficult for me to get any work done today because I've got to go into work, but I'm going to keep thinking about this now.
It was really awesome. Thank you, guys.
Yeah, thanks for coming on.
All right, folks, we will catch you in the next episode. That's it for the show, folks. Fragmented is hosted by DonnFelker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.